Plastics have revolutionised the way we live. They're just so convenient. They're strong and have great longevity, which is why they're often used for packing materials. But that longevity is causing an environmental impact, especially when you consider getting rid of single-use items. This classroom experiment will investigate how different washing conditions of fleecy materials, such as found in school uniforms, will vary the amount of microplastics released into our water systems. Can you tell me, what experiment are we going to do today?
Yes, so today we'll be investigating what happens when you wash fleeces into different conditions and the microfibers and the microplastics that it releases into the water.
Perfect. So now, what equipment do you need for this experiment?
So we would need 2 beakers, we would need a funnel, filter paper, and fleeces, of course.
Yeah, you've got different types of fleeces there.
Yes, different types of fleeces to see how much microplastics and microfibers it releases. We have salt, we've got our magnifying glass, yes, so we've got our washing up liquid, we've got our stopwatch and a thermometer to see the effect that temperature has on the release of fibers.
Yeah, you've got a magnifying glass. That helps you see the fibres, or are they fairly visible?
Some of these fibers are visible, but there are a lot of microfibers and microplastics that can't be seen without a magnifying glass.
So that's the equipment we need, but how do you actually conduct the experiment?
Yes, so we would start with doing the control as a whole class. So you would get some fresh water and put that in the beaker from the tap, and then you will filter that. You need to do that to make sure that there's nothing left behind from the tap or from the student's uniform or their lab coat. And once you filter that, you have got fresh water, and you will get a piece of fleece and wash it in the beaker. Once you've washed that in the beaker, you filter that again to separate the microfibers and microplastics from the actual water. And you'll need another beaker to collect that water, that filtered water in.
So you've set your control, your baseline. So how do you develop the experiment further?
Yes, so students have the opportunity to design their own experiment. So they've got different materials that they can choose from. We've got the washing up liquid to test the effect that washing up liquid has on the release of the numbers of fibers. We've got sodium chloride, salt, to test the effect of salt. We've got a thermometer to test the effect of temperature, and then we've got the timer to test the effect of the time and how long we keep the fleece in there and the amount of fibers it releases. So each group will design their own experiment and collect their own data.
Perfect. But I do like setting the baseline, and then from that you can look at how each one of these has an effect, and
Yes.
do you get more fibres, less fibres, and so you get an understanding of the different parameters.
Yeah.
I really like this experiment because all those different parameters, they're sort of almost like settings on the washing machine at home, and so it really does bring it to life.
Yes, exactly. So that helps to create the real life experience and bring that into the classroom, which makes the practical more interesting for the students as well.
Are there any handy hints for this experiment?
The main one would be for students, to show students beforehand how to fold the filter paper in a cone shape. So you would tell them to fold it in half first, and then fold it in half again. And then you'll get this lovely triangle. And then they get a piece of it, and then you put your cone shape, and they put it into the funnel.
Yes, I suppose that's quite important because you don't want water going round.
Exactly.
You want to catch all the fibres that are released.
And students tend to get stuck in that process, so if you explain that to them beforehand, it might smooth up the process.
Get it done up front.
Yeah, exactly.
That makes sense. And so, are there any health and safety concerns with this experiment?
Not really with this experiment. The main issue would probably be spillage, but if you make sure that you give students paper towel, and tell them to clean it up immediately, then you would prevent anyone from slipping. Okay,
yes, because you use hot water, but what sort of temperature are we talking there?
It will be max 35 degrees Celsius.
Okay.
Yeah.
Yeah, so sort of nice to hold, but nothing dangerous.
Exactly, yes, to keep it safe, yeah. I want you to wash the different types of fleeces and then compare which fleece is releasing more fibre.
Guys, we need the funnel as well. Oh, wait, we're out. There's something in there.
What we're going to do next is we'll open the filter paper put it on the table, and then you can have a look through the magnifying glass to see all the little microfibers.
The filter is like stopping the fibers from passing through the funnel.
Okay, guys, so you've done the first part of the experiment. You've set up the control. So did you see any differences between the different materials you used?
I saw that there's like different quantities of the microfibers that were released.
You think the fleeces with the longer fibres produced more fibres in the end?
Yeah.
Oh, that's very interesting. Thank you.
So we've all tested what would happen if we just used fresh water. What we're going to do now is we're going to test it in different conditions. So in your groups, you'll be able to design your own experiment.
So we're seeing like how temperature will affect like the fibre.
How much fabric will end up as a residue in the filter paper?
Depending on the temperature.
And you're trying to keep everything the same, because I guess keeping everything constant. Do you know where it's cut? You've got lots of fibres loose. And so if you put that in the water and then take it out, even if you put it in exactly the same thing, most of the loose fibres are now free. So you might get less automatically because of that. So maybe sort of using another sort of freshly cut piece might give you a different result.
I feel like the sodium chloride has made the fabric stronger and it like keeps it together.
Did you think you did the same agitation, the same sort of things with this one as you did in the last one? Because I guess that's quite important so you can make the comparison. So that's without salt and that's with salt. The difference is quite amazing.
In science, there's nothing right or wrong.
No, I guess we come up with an idea, we test the idea. Sometimes when we test it, it sort of agrees with what we think. Sometimes it doesn't. And if it doesn't, then we sort of do other experiments to see why our idea went wrong.
Why is it bad for the environment that these fibers get released?
If fibers get released into the ocean, it shows that like the ocean wouldn't be like very clean and it could like pollute the ocean. Yeah.
Us humans, we eat animals, and like when animals consume those like different materials that are poisonous, like it ends up going into our bodies as well, and it's like it's harmful for us.
As you say, we eat them, they eat them. It's not a good thing, is it? From this experiment, have you concluded anything about how often you're going to wash your clothes?
I think that instead of changing how long we use our clothes and wash them, we should be changing the way and the soap that we use to wash our clothes with, because from our experiment we've seen that using salt doesn't allow as many fibers to come through the material, which could end up leaving less fibers in the ocean.
This talk about microplastics and these microfibers is quite a topical thing. You hear it in the news all the time, it's sort of quite a worry. What are the sort of the learning points, the things that students will take away from this?
So students will learn and see the effect of their clothes and the different materials they're made up of. So they can see the effect that synthetic materials, these fibers that they release, they will stay forever and they can go into our water system, into the ocean, and have a negative impact on our ecosystem.
Yes. And I suppose this is a lovely experiment to do within a class, but is there a way of the students sharing this with the other students of the school? Because, as I say, this is very topical.
Yes, so as an extension, what students could do is you can ask them to create a poster or a flyer explaining the importance of having natural resources as materials and thinking about different, the effect that the materials could have on the environment.
So it's a fascinating experiment, and I guess there's quite a bit of chemistry in here, but are there other ways that it relates to the curriculum?
Yes, so the chemistry that is linked to the curriculum would be mainly solubility and separating mixtures, and also for biology about the ecosystem, and bioaccumulation ties into it as well, and how synthetic materials get released into the ocean.
Okay, yes. I suppose there's quite a bit going on there.
Yeah.
And it isn't just about the chemistry, it's about sort of many other things like
Yes.
ecology and biology as well.
It's very interlinked.
How do you think they will learn from this? And do you think it will influence them in the future in the decisions they make?
It definitely would, because it's very interesting to see the amount of fibers and microplastic a fleece can release when you wash it. The fact that it could go into our water system and into the ocean, into other other animals and back into our bodies. And it's very interesting for students to have a practical that brings the real life experience into the classroom.
Today, we've seen how a simple experiment can really raise awareness of a global concern. And this experiment covers such a wide range of curricula. We're talking chemistry, biology, looking at ecosystems and bioaccumulation. One of the things I loved about it is it gives the students autonomy. They can devise their own experiments. But best of all, it arms them with knowledge that they can take home so they can make changes for themselves which have a real world impact.